Hi, welcome to the third algebra tutorial. Today's tutorial is titled Quadratic Equations and is a follow-on from the previous algebra tutorial, which was titled Factorization. In terms of what you need to know to progress with this tutorial, you need to be familiar with your grade 10 work, as well as have recently gone through the first two algebra tutorials titled Basic Algebra and Factorization. We will begin this tutorial from where we left off the previous tutorial. You will recall that towards the end of the previous tutorial, we were looking at factorization as a technique of finding the value of the unknown variables in a quadratic equation. That is, an equation of the form ax squared plus bx plus c is equals to 0. We will start this tutorial by doing a quick recap of factorization. We will then move on to two other techniques that we can use in order to find the value of the unknown variables in a quadratic equation. Let us take a recap of factorization. The example I'm going to use is x squared plus 3x minus 10 is equals to 0. That will factorize to become x plus 5 times by x minus 2 is equals to 0, which will become x plus 5 is equals to 0 or x minus 2 is equals to 0. That means that either x is equals to negative 5 or x is equals to 2. This method was very easy to use in this case because that expression x squared plus 3x minus 10, we could factorize it. I'm going to use that same example of x squared plus 3x minus 10 through the next two techniques to explain the next two techniques, but remember that the next two techniques we use when we cannot factorize. And you will see it still gives us the same answers. The second technique we can use if we can't factorize is called completing the square. X squared plus 3x minus 10 is equals to 0. I will start by keeping the x's on one side and taking the constants to the other side. That will become x squared plus 3x is equals to 10. I'm then going to each side add b over 2 squared. That will become x squared plus 3x plus b over 2 squared is equals to 10 plus b over 2 squared. Remember, what I do to the left hand side I have to do to the right hand side. That is the golden rule of equations. The b value in this case is 3. Remember, of our standard equation, it's in the form ax squared plus bx plus c. That means that in this case our a value is 1, our b value is positive 3, and our c value is negative 10. The equation will read x squared plus 3x plus 3 over 2 squared is equals to 10 plus 3 over 2 squared. To the left hand side, I'm going to factorize that. That is going to become x plus 3 over 2, all in brackets, squared. Now on the left hand side, I don't need to take that 3 over 2 squared and multiply it out or square it. All I need to do is say x plus 3 over 2 and all of that squared is equals to 10 plus 9 over 4. Now on the right hand side I am going to multiply it out. That means that x plus 3 over 2 squared is going to equal 49 over 4. X plus 3 over 2 is therefore equals to the square root of 49 over 4. But remember that the square root of something can always either be negative or positive. Negative 3 squared is equals to positive 9. Positive 3 squared is also equals to positive 9. That means that the square root of 9 can either be equals to positive or negative 3. The same principle applies to any number that we are squaring. That will read x is equals to plus or minus root 49 over 4 minus 3 over 2. Now break it up. The reason we have plus or minus is because it could either be positive or negative. That means that x is either equals to positive 7 over 2 minus 3 over 2, which is equals to 4 over 2, which is equals to 2, or x is equals to negative 7 over 2 minus 3 over 2, which is equals to negative 10 over 2, which is equals to negative 5. Notice something, that completing the square gave us the same two x values as did factorization, and it should. The third method we are going to be looking at is the quadratic formula. The quadratic formula says that the x values are equals to minus b plus minus square root of b squared minus 4ac all over 2a. Again, we are using the standard formula ax squared plus bx plus c. That will read x is equals to minus 3 plus minus square root of 3 squared minus 4 times 1 times negative 10, all of that divided by 2 times 1, which will read minus 3 plus minus square root of 9 plus 40 divided by 2, which is minus 3 plus minus square root 49 over 2, which means that my x values are either going to be minus 3 plus 7 over 2, which is equals to 2, or minus 3 minus 7 over 2, which is equals to negative 5. Again, it gave me the same two x values, and it should. Now I want you to do the same to the following. X squared plus 4x minus 12 is equals to 0. First, I want you to use factorization to find the two x values. Once you have done that, I want you to apply completing the square to this equation to see if you come to the same two x values, and then I want you to use the quadratic formula. The example I'm using is x squared plus 4x minus 12 equal to 0. I want to find my x values that make this make sense. Now this is a very easy one. We can factorize. We can use the technique called factorization to turn this into x plus 6 multiplied by x minus 2 is equal to 0. That means that either x is equal to negative 6 or x is equal to positive 2. This is a nice method to use when it can be factorized. In fact, I'd suggest you always try and use factorization before anything else. Problem though, what happens if this was a negative 13 at the end? Then it cannot be factorized. But there are still two different x values that are going to make this make sense. I'm going to run through two techniques we can use to find those different x values when we cannot use factorization. Remember, it's always got to be in the form ax squared plus bx plus c equal to 0. Let's just write that out here. x squared plus bx plus c equal to 0. In this case, our a value is 1, our b value is positive 4, our c value is negative 12. The first method I'm going to look at is called completing the square. The second method I'm going to use is called the quadratic formula. Make sure that you've got your scientific calculators at hand. Let's start by completing the square. Now we are going to look at completing the square as a technique for finding our two x values that make this true. I'm going to start by saying x squared plus 4x is equal to, take the 12 across to make it positive 12. I'm then going to say x squared plus 4x plus 4 over 2 squared is equal to 12 plus 4 over 2 squared. I added 4 over 2 squared to my left hand side. I'm going to add it to my right hand side. Golden rule of algebra: what you do to one side, you do to the other. This is going to become x plus, now 4 over 2 is the same as 2, x plus 2 squared is equal to 12 plus 4 over 2 is 2, 2 squared is 4. That means that x plus 2 squared is equal to 12 plus 4, which is equal to 16. X plus 2 will equal, to get rid of the squared, I square root that side. What I do to one side, I do to the other. Square root cancels out the squared. That means that x plus 2 is equal to square root of 16. Yes, almost there. Problem is that a square root can either be positive or negative. Think about this. 3 squared is equal to 9. Negative 3 squared is negative 3 times negative 3, which is going to give us positive 9. They both gave the same answer. That means that square root of 9 will either equal positive 3 or negative 3. Alright? In this case here, square root of 16 can either be positive or negative. That means that I've got two different values. My first is x plus 2 is equal to positive root 16, and my second possibility is x plus 2 is equal to negative root 16. Now root 16 we know is equal to 4. That means that the answer here would be x plus 2 is equal to positive 4. That means that x is equal to 4 minus 2, which is equal to 2 positive, or x plus 2 is equal to negative 4, which means that x is equal to negative 4 minus 2, which means that x is equal to negative 6. Notice my two answers, x is equal to 2 and x is equal to negative 6, are the same two answers I got from factorizing. Obviously, if you get any question that can be factorized, first factorize it. Don't try and complete the square if you can factorize it. Now let us look at the third method, called using the quadratic formula. The quadratic formula always starts off with a sum in the form ax squared plus bx plus c equal to 0. Our a in this case is 1, our b is positive 4, and our c is negative 12. The quadratic formula says that our two x values are given by x is equal to minus b plus or minus square root of b squared minus 4ac, all of that divided by 2a. You will find this formula in the formula sheet, but be comfortable with using it, and I'd suggest you memorize it. It's not that difficult. Also, because of this plus minus, we are going to get two different x values. The one value is going to be given by minus b plus square root of b squared minus 4ac over 2a, and the other x value is minus b minus square root of that over 2a. Plugging the values in, our b value in this case is positive 4. Positive times a negative is negative. Negative 4 plus or minus b squared, which is going to be 4 squared, minus 4 times a times c, which is negative 12, over 2a, which is 2 times 1. Remember, our a value was 1. This will equal minus 4 plus minus square root 4 squared is 16, minus 4 times 1 is minus 4, multiplied by negative 12 is going to give me positive 48. 12 times 4 is 48, negative times a negative is positive, times 1 is just 1. And that's divided by 2a, which is very simply 2 times 1. 2 times 1 is 2. That's going to equal minus 4 plus or minus square root 16 plus 48 is 64 over 2, which means that our 1x value is equal to minus 4 plus root 64, which is 8 over 2, and our other value is x is equal to minus 4 minus root 64, which is 8 over 2. Minus 4 plus 8 will give me positive 4 over 2, which is equal to 2, or x is equal to minus 4 minus 8, which is negative 12, over 2 is negative 6. Notice that my two answers are again the same two x values I got when I used factorization and when I used completing the square. I want you to keep in mind though that completing the square is sometimes a fairly tedious task, especially with the calculators that you guys are using at the moment. Using the quadratic formula is much easier. Now I want you to have a go at the following 10 examples. The first 5 involve completing the square, and the next 5 I want you to use the quadratic formula for. Welcome back. The first 5 I gave you were completing the square. The first one read x squared plus 8x minus 8 is equal to 0. I'm going to start by making this x squared plus 8x is equal to positive 8. X squared plus 8x plus 8 over 2 squared is equal to 8 plus 8 over 2 squared. What I do to one side, I do to the other. 8 over 2 is equal to 4, so this is going to become x plus 4 squared is equal to 8 plus 8 over 2 is 4, squared is 16. That means that x plus 4 is equal to square root plus minus of 8 plus 16, which is 24. That means that our two possible options are x is equal to positive root 24 minus 4, taking that across, or x is equal to negative root 24 minus 4. Those are our two options. You can simplify it further with the calculator if you want to. I'm just concerned that you got to this point. Beyond that is up to you. The next one I gave you to do read 2x squared, number 2, 2x squared plus 6x minus 8 is equal to 0. This is going to become 2x squared plus 6x is equal to positive 8. Get rid of that 2. Always get it, if we're completing the square, always get that to a 1. So that will become x squared plus 6 divided by 2 is 3x is equal to 8 divided by 2, which is 4. This will become x squared plus 3x plus 3 over 2 squared is equal to 4 plus 3 over 2 squared. This is going to become x plus 3 over 2 all squared is equal to 4 plus 9 over 4. 3 over 2 squared is 9 over 4. Turn that 4 into 16 over 4, so I've got a common denominator. This means that x plus 3 over 2 is going to equal positive or negative square root 16 plus 9 is 25 over 4. That means that either x is equal to positive root 25 over 4, which is equal to 5 over 2, 5 over 2 minus 3 over 2, which is going to equal 1. 5 minus 3 is 2, 2 over 2 is 1, or x is going to equal minus 5 over 2 minus 3 over 2, which will equal negative 8 over 2, which is the same as negative 4. That means that our two possible answers are 1, x is equal to 1, or x is equal to negative 4. The third one that I gave you to do read 3x squared plus 4x minus 7 equal to 0. This is going to become x squared plus 4 over 3x minus 7, plus 4 over 3x is equal to 7 over 3. Took the 7 across, divided everything by 3. This is going to be x squared plus 4 over 3x plus 4 over 3 over 2 squared is equal to 7 over 3 plus 4 over 3 over 2 squared. Now 4 over 3 over 2 is the same as 4 over 3 divided by 2 over 1, which is the same as multiplied by 1 over 2, which is equal to 4 over 6. So this will become x plus 4 over 6 squared is equal to 7 over 3 plus 4 over 6 squared is going to give us 16 over 36. Make 36 a common denominator. I had to multiply 3 by 12 to make it 36. 7 multiplied by 12 is 84. That means that x plus 4 over 6 is equal to positive or negative square root 84 plus 16 is 100 over 36. That means that x is either equal to positive square root of 100 over 36 is 10 over 6 minus 4 over 6. 10 minus 4 is 6 over 6 is 1, or x is equal to negative 10 over 6 minus 4 over 6, which is equal to negative 14 over 6, which can be simplified to form negative 7 over 3. Number 4 read 2x squared minus 9x minus 21 is equal to 0. That means that x squared minus 9 over 2x is equal to positive 21 over 2. This will become x squared minus 9 over 2x plus 9 over 4 squared is equal to 21 over 2 plus 9 over 4 squared. This will become, now the previous examples have all been plus bx. This one is minus bx. So this is going to become x minus 9 over 4 all squared is equal to 21 over 2 plus 9 squared is 81 over 4 squared, which is 16. Common denominator of 16, which means that I had to multiply 2 by 8 to get to 16. 21 multiplied by 8 is going to give me 168. That means that x minus 9 over 4 is equal to positive or negative root 168 plus 81 is 249 over 16. That means that x is equal to positive root 249 over 4. Square root of 249 over 16. Square root of 249 doesn't give us a whole number, so I'm going to just leave it as square root of 249 divided by square root of 16, which is 4 plus 9 over 4, which is equal to 9 plus root 249 over 4, or x is going to equal 9 minus root 249 over 4. You can work these two answers out on your calculators if you want to, but you don't need to. This is as far as you need to go. This is in its relatively simplest third form. The 249 probably could be simplified a bit further. Number 5 read x squared minus 2x plus 20 is equal to 0. This will become x squared minus 2x plus 2 over 2 squared is equal to negative 20 plus 2 over 2 squared. 2 over 2 is 1. This is going to be x minus 1 squared is equal to minus 20 plus 1 is minus 19. This means that x minus 1 is equal to positive negative root negative 19. Problem: square root of a negative has got no solution. No real solution. Hence, that is our answer. There are no solutions to x. there are no x values that will make this negative. Rather, that will make it 0. The first quadratic formula expression I gave you was 3x squared minus 3x minus 10 is equal to 0. Remember that the quadratic formula is x is equal to minus b plus minus square root of b squared minus 4ac divided by 2a. My b value is minus 3 plus minus square root of minus 3 squared minus 4 ac divided by 2a, which is 2 times 3. Minus times a minus 3 is going to give me positive 3 plus minus square root of minus 3 squared is 9. Minus 4 times 3 is minus 12 times minus 10 is going to give me positive 120. All of that divided by 2 times 3, 6. That's going to give me 3 plus or minus square root 129, all divided by 6, which means that my two x values are going to be x is equal to 3 plus root 129 divided by 6, or x is equal to 3 minus root 129 over 6. Again, if you want to work this out further with your calculators, you can, or you could just leave it as is. The next one we're looking at, number 2, says 6x squared minus 2x minus 12 is equal to 0. Quadratic formula says that, let me write that in another color. In every example, I'm going to write that in. X is equal to minus b plus minus square root of b squared minus 4ac over 2a. In this case, x is equal to negative 2 minus b plus minus square root of b squared minus 4ac divided by 2a. That's going to equal positive 2 plus or minus square root of 292 over 12, or, oh no, that's it. So the two possible options are x is equal to 2 plus root 292 all divided by 12, or x is equal to 2 minus root 292 over 12. Now compare this question that I just did with the previous one. The previous one looked a lot messier. It had much more steps in between. Remember that you are using a scientific calculator, so all of this can simply be done on the calculator. The third one I gave you to do read 9x squared plus 28x minus 100 is equal to 0. We're using the formula x is equal to minus b plus or minus square root of b squared minus 4ac, all of that divided by 2a. Which means that in this case, x is going to equal negative 28 plus or minus square root of 28 squared minus 4ac. Remember, c is negative 100 over 2a, which is 2 times 9. That will yield a result of negative 28 plus square root of 4384 divided by 18, or negative 28, rather x is equal to negative 28 minus root 4384 over 18. These are our two x values. I don't expect you to take it any further than that. The fourth one I gave you to do read 2x squared plus 4x plus 4x minus 100 is equal to 0. Remember, we're using the formula x is equal to minus b plus minus square root of b squared minus 4ac over 2a. That means that in this case x is going to equal minus 4 plus minus square root of b squared, which is 16 minus 4ac. Let's just leave that as 4 squared over 2 times 2, which will give us an answer of minus 4 plus root 816 over 4, or x is equal to minus 4 minus root 816 over 4. Number 5. 4x squared plus 2x plus 8 is equal to 0. Formula: x is equal to minus b plus minus b squared minus 4ac. So it's minus b plus minus b squared minus 4ac over 2a, or 2 times 4. 4 times 4 is 16 times 8 is going to give me 128, but that's going to be negative. So my square root is going to read 4 minus 128, which is square root of negative 124. We cannot get the square root of a negative number. Hence, for number 5, there is no solution. And you can check that using completing the square, that you will also come to no solution. And that brings us to the end of the third algebra tutorial, quadratic equations. Before you move on to the next tutorial titled Simultaneous Equations, I want you to go through the exercise that I have left for you in the workbook. Just a quick word on the techniques that we have used today. Once you become more familiar with using the quadratic formula, you will notice that it becomes a lot easier to use than completing the square. My advice to you is this: if you have a quadratic equation that you cannot factorize by inspection, move on to the quadratic formula. Don't waste your time trying to factorize it, and don't frustrate yourself trying to complete the square. Completing the square is important, however, when we move into analytical geometry.